In this lesson, we'll talk about order of operations and properties of real numbers. Let's recall the sign rule for multiplication, division, or double sign. If we multiply two positive numbers or two negative numbers, the result of this multiplication is positive. However, if we multiply two different signed numbers, positive with negative or the other way around, the result will be negative. The same applies to division or double sign. That means if we, for example, add a negative number, we can replace this double sign by a single sign negative. Or if we subtract a negative number, we'll replace these two signs by a positive. We also should recall the rule for order of operations, BEDMAS. What those letters stands for. I'm sure you remember that B stands for brackets, but not only brackets, any grouping signs. For example, division bar, it's a grouping sign. It separates the numerator and the denominator. So we first calculate whatever is in the numerator, it could be a big expression, then whatever is in the denominator, and this division bar works like a bracket for a numerator and bracket for the denominator. Also, absolute value, it's a grouping sign. We calculate the value of the expression inside before we apply absolute value. Okay, so when we evaluate any expression, the first priority is to perform everything what's in grouping signs. And if the grouping signs are nested, like nested brackets, you perform the operations within the most inner bracket first. Then, when we finish with grouping signs, the next priority would be to look for exponents. Perform all the exponents. And finally, we have four operations: division, multiplication, addition, and subtraction. Division and multiplication have priority over addition and subtraction, so that means we perform them first. If we have a choice between, for example, multiplication or addition or subtraction, we perform multiplication. The same is with division. However, if we need to decide between division and multiplication, they are actually equally important. So we have a sub-rule. If we see a few operations in a row composed of division or multiplication only, we perform those operations from the left to the right. So whatever comes first, it's done first. So the fact that D is before M in the BEDMAS mnemonic doesn't mean that division is supposed to be performed before multiplication. Not at all. They have equal priority. Whatever comes first is performed first. We'll see some examples on the next slide. Okay, finally, after division and multiplication, we perform addition and subtraction. And these two operations, again, they are equally important. There's no priority between them. So the sub-rule is the same as for multiplication and division, from the left to the right. Whatever comes first, you perform first. Okay, what else do we need to review? Powers. If we want to multiply the same number or expression n times, to make this easier to record, instead of multiplying so many times, we use power notation. So let's recall, if we multiply a by itself n times, a becomes the base and n becomes the exponent. So a to the n represents multiplication of a by itself n times. And the overall thing is called power with the base a. Okay, let's look at these two examples. Very important to remember that exponent refers to the immediate number only, or everything that's in a bracket. So in this case, we have a bracket -3 square. That means that we multiply -3 by itself twice. So the outcome is positive 9. However, if we write this without a bracket, then the exponent refers only to the immediate number. It does not refer to the minus. The minus is not under the jurisdiction of exponent 2. So that really means that we can copy the minus, and then the square refers to the 3, therefore we multiply 3 by itself twice. As you see, this ends up to be just a single minus, so the outcome is -9. So please pay attention how you write your powers and what we are actually squaring, either with the bracket or without the bracket. That makes a big difference. Let's practice some examples. We'll start with this simple example, 2 plus 2 times 2. If you would just hear it without seeing the operations, it's very easy to make a mistake with the answer. I ask this question many times in my classes. I ask my students to close their eyes and just shout the first answer that comes to their minds after I will tell them 2 plus 2 times 2. Usually part of the class shouted 6 and the other part 8. Well, let's see. According to the order of operations, we're supposed to multiply first and then add 2. So we end up with 2 plus 4, which is 6. Second example, now we need to start with brackets first. So whatever is in the bracket, perform first. Therefore, we need to copy everything else. Copy patiently, don't lose anything, and perform one operation at a time. Negative 5 plus 2 is negative 3. And then we have 7, and the rest of it we can treat as a product of negative 3 and negative 3, which is plus 9. So we record plus 9. Or someone could think of subtract a product of 3 times negative 3. So that will be subtract negative 9, which is still positive 9. So no matter how you look at it, these two negatives will make the final answer positive for this part of the question. And finally, 7 plus 9 is 16, so that's the overall answer. Another example. This time I will stress that you actually write every single step. I know that sometimes it may be annoying to rewrite everything because some of you may feel, oh, I remember this and I remember that, and I will subtract in my head and I will give the final answer. But the important thing is to learn the method, get used to writing every single step, because as soon as your question will be longer or more complicated, keeping in your mind or writing partial answers somewhere on your paper may lead to lots of mistakes. So every time you rewrite the question, do it in such a way that if someone will cover the previous line, you will still have all information needed to complete the question. So I'm going to copy the minus and I'm going to write this big square bracket. Inside the bracket, I see that I need to subtract 2 powers, 2 squares. So according to order of operations, I'm supposed to perform those exponents first. But even before that, I have another bracket here that needs to be performed as first, the most inner bracket first. This one, there's nothing to perform, so I can actually square it. Negative 3 squared is 9. Here I copy the minus, and here let's rewrite what's in a small brackets. 4 minus 9 is negative 5, and this negative 5 needs to be squared. But let's do it in the next line. So that equals, copy the negative, 9, copy this minus, and then negative 5 squared is positive 25. Okay, now again copy the minus, and I can actually perform this bracket. 9 minus 25 is negative 16. Oh, now I have double negative. That turned out to be positive 16 in the end. Okay, next example asks us to divide fractions. Since we usually don't like to divide by fractions, remember the rule is change this division sign into multiplication and flip the second fraction into reciprocal. So convert division question into multiplication question by the reciprocal of the second fraction. However, even before that, let's combine our signs. Since we divide a negative number by a negative number, the final answer is positive. We don't really need to write as positive, but we keep this in mind. There's positive, so we can neglect those two negatives. They actually cancel each other. Okay, therefore we get 3/4 and then multiply by a reciprocal of this number regardless of the sign. So 6/5. Now, I suggest that we try to reduce whatever it's possible. For example, 4 can be reduced with 6 by 2. 2 goes into 6 3 times, 2 goes into 2 2 times, and now we are ready to multiply numerator by numerator and denominator by denominator, so we get 9/10. Could be written as a fraction, could be written as a decimal, 0.9. Another example, we need to add two fractions, but we also have a power. So exponent needs to be performed first, And how do we cube a fraction? Well, we cube the numerator and we cube the denominator. So negative 2 cubed is negative 8, because it's like negative 2 times negative 2 times negative 2. 3 negatives end up to be negative. And 3 cubed is 27. 3 times 3 times 3. Then we need to add 2/3. However, remember when we add fractions, we need a common denominator, and the common denominator for these two is 27. So we need to extend this fraction to the denominator 27. What do I need to multiply 3 to get 27? Oh, it's 9. So since I want to multiply denominator by 9, I have to do the same to the numerator. Multiply also by 9. And now I'm ready to add those fractions. So let's write them under common denominator, which is 27. And here I have negative 8. And over there plus 2 times 9, which is 18. 18 minus 8 is 10. So we end up with 10 27ths. Another example, absolute value of this expression. What do we have inside? What kind of operations? We have subtraction and we have division. So, among these two, division has a priority. Let's divide first. Copy everything else. So, negative 5, negative 16 divided by 2 is 8. Now, I still need to perform whatever is inside this grouping sign, which is absolute value. So, let's perform this subtraction. Negative 5 minus 8 is negative 13. Copy the absolute value. And finally, absolute value of any number ends up to be a positive number, so it's 13. Okay, let's do a couple more examples. What do we have here? How do you think, what operation is between negative 4 and this absolute value? Yes, it is a multiplication, even though we don't see it. So we have negative 4 times absolute value that works sort of like a bracket, but more than a bracket. So let's perform whatever's inside this absolute value first. Copy the negative 4, absolute value, and then we have 2 minus, we need to perform square root of 0.25. What square root of 0.25 may be? Well, if this will be just 25, square root of 25 would be 5. Therefore, square root of 0.25 must have something to do with 5. However, we need to look at the decimal dot. Remember, when we multiply decimals, we move the decimal dot in a product by as many places as many it was in both numbers. So if we choose 0.5, we have one place value in this number, but then multiply by another 0.5, it will be 2 places that we need to move our dot in the answer. So root of 0.25 would be 0.5, and complete the absolute value. Now what we still need to do is perform the subtraction inside the absolute value. So 2 minus 0.5, how much this may be? You can think of this like 2 chocolate bars minus half a chocolate bar. How much is left? 1.5. So you can write 1.5 and complete absolute value. Okay, but absolute value of 1.5 is still 1.5. So now we can multiply 1.5 by negative 4. Therefore, the answer should be negative 4 times 1.5 is 6. Negative 6. Now, why don't you pause the video and try these two examples on your own? And when you finish, resume the video and see how it was done, or check your answers. What do we have here? It's a division bar that works like grouping sign. So we need to perform whatever's in the numerator, which is subtraction of 2 powers. So let's perform those powers first. Negative 3 square is 9. Then we have a subtraction, and then we focus just on negative 2 cube. So negative 2 when cubed ends up to be a negative number because we are multiplying 3 negative numbers. Odd powers of negatives ends up to be a negative. So since we have 2 signs in a row, it's a good idea to put a bracket. Therefore, inside the bracket we have negative, and 2 cubed is 8. Over, and let's see what we can do in the denominator. We have a subtraction. Here we have a root, which falls into exponent rules. Remember, square root works the same as exponent 1/2. And then after subtraction we have a multiplication by absolute value. So we can perform whatever is inside the absolute value, and we can perform the square root of 16 because those two areas are disjoint by the subtraction. So yes, we could perform both of them at the same time. Okay, root 16 is 4. Copy the negative, copy the 3, copy the absolute value, and inside the absolute value is 4 minus 5, so it's negative 1. Okay, the expression looks shorter already. Now I would suggest that we rewrite the numerator with one sign at a time. So this double sign should be replaced by a plus. Negative 9 plus 8 over 4 minus 3, and instead of absolute value of negative 1 we have just single 1, so times 1. Okay, now we can finish the numerator. 8 minus 9 is negative 1. In the bottom we have 4 minus 3 times 1 is just 3. So 4 minus 3 is 1 as well. So overall the final answer is negative 1. Let's check the last example. What do we have here? 11 minus 2 and big absolute value. So copy this absolute value and see what's inside. Oh, inside we have two operations, multiplication and division. This needs to be performed from the left to the right, remember, because multiplication and division are equally important, so we use the sub rule from the left to the right. Multiply first. 8 times negative 2 is negative 16, and then divide by negative 2 squared, which becomes just 4. Okay, we can move this absolute value bar a little bit closer. It will be here. And simplify again. So now we have 11 minus 2 times absolute value. So brackets supposed to be performed first. But also remember that between subtraction and multiplication, multiplication works stronger. So this 2 is strongly connected with the absolute value expression. Many students make mistake by subtracting the 2 from 11. But actually this subtraction needs to be performed as a last step. So let's copy 11 minus, copy the 2, and inside the absolute value we have negative 16 divided by 4, so it's negative 4. Now it's time to drop absolute value and see what we have. So again, it's 11 minus 2 times positive 4. Absolute value of negative 4 is positive 4. And finally, between the subtraction and multiplication, we need to perform multiplication first. So copy the 11 and subtract 2 times 4, which is 8. Therefore, 11 minus 8 is 3. Final answer. Here we go. I hope you've got 3 as well. Now let's recall a couple more rules about simplifying expressions. For example, if we have a fraction, to write a minus in front of the fraction means the same as to write the minus in the numerator or in the denominator, but not in both. So it doesn't matter where do you write your minus, but it does matter how many minuses within the fraction is there. If it's odd number of minuses, you always replace it with a single minus. If it's even number of minuses, you drop them because they become positive. For example, here there's even number of minuses, so that's the same as just a over b with a plus. A plus doesn't have to be written. Also remember that the square root of a negative can't be taken. It doesn't exist. DNE stands for doesn't exist. And root of x squared is not x by itself. It's actually absolute value of x. Why it is so? Well, because x by itself could be a negative number, and remember that root of anything is actually positive. Okay, now let's review how do we evaluate expressions. Here we have two examples. Given the values for a, b, and c, evaluate these two expressions. So here we need to keep in mind order of operations. I would strongly suggest that when you evaluate any expression, you prepare a bracket for any unknown letter. So here for a and b. So what do we have? We have actually 2 times a divided by 3 times b. I placed brackets instead of a and b. Now plug in inside those brackets the values A is -3, so we use -3 for this bracket, and B is equal to 4, so plug it in 4 in that bracket. And now as you see, this becomes a regular order of operation question. What do we see here? It's a multiplication, division, and multiplication. Remember, the sub-rule is we perform those operations from the left to the right. So we perform this multiplication first, it becomes -6, and copy the rest. Divide by 3 times 4. And again, from the left. Okay, -6 by 3 is equal to -2. And copy the times 4, which equals -8. Have you reached the same answer? If you did, you deserve a happy face. This question, even though it looks like simple, it's actually quite tricky. Usually people multiply 2a, multiply 3b, and then divide. That's not what it's supposed to be done here, since we don't have a bracket around 3b. We're supposed to divide by 3 and then multiply by b in this case. Okay, let's look at next example. Again, I will rewrite the whole expression using brackets for every a or b or c. So we have root of a plus b minus 3 times a squared. Everything over 2 times c. Let's plug in the values. A is -3, b is 4, a -3 again, and c is -1/2. Now we're ready to simplify. So, root of -3 plus 4 is like root of 1, 4 minus 3. Okay, -3 times -3 squared, remember that becomes +9. So it's times 9 over, and then we could actually reduce this 2 with that 2, so denominator becomes -1. -1 here. Okay, let's continue. Now we have root of 1 is 1 minus 3 times 9 is 27, everything over -1. So that becomes -26 over -1, which finally gives us +26. Okay, that's done. Now let's review properties of real numbers. I'm sure you learned about it in previous math courses, but here we want to look at those properties again just to recall. Commutative property. It applies to addition or multiplication. That's the property when you can change order of numbers and the result is still the same. Notice that subtraction and division won't work. For example, 4 subtract the 2 is not the same as 2 subtract the 4. So subtraction is not commutative. Neither is division. 4 divided by 2 is not the same as 2 divided by 4. This is 1/2 and this is 2. So only addition and multiplication are commutative. The next, associative property. That's a property when you can change the position of a bracket. This bracket tells me that on the left hand side I add first b plus c and then I add a. However, on the right hand side I add a and b and then I add c. Again, this property applies to addition and multiplication. It does not apply to subtraction or division. For instance, I could give you counterexample for division. If we start with 8 divided by 4 divided by 2 and put a bracket like this is not the same that 8 divided by 4, place the bracket and then divided by 2. Please check this on your own, see why it's not the same. The next property is called inverse property. An inverse number to the given number a is -a. So that's the additive inverse. And the inverse for multiplication is actually called reciprocal. So 1 over a, it's a multiplicative inverse to a, because when we multiply 1 over a times a, we end up with 1, which means nothing for multiplication. Obviously, the multiplicative inverse exists only when a is not 0. Here with addition, the same rule. If we add a number to its additive inverse, we end up with 0, which means nothing for addition. And next property is called identity property. So this is the nothing, this is the identity for addition. You can add it from either side to the a, and that doesn't change the value a. Similarly, multiplicative identity, you can multiply by 1 from either side of a, and the a doesn't change. If you multiply anything by 0, the value will be always 0. And finally, the very useful property, distributive property. We can distribute the multiplication by a into the bracket, either for addition or subtraction, by multiplying the bracket a times b, plus or minus, depending which sign was there, a times c. And this multiplication by a may happen from the left or from the right. The distributive property works the same way. So here we would multiply a times b, which is here, and a times c, which is over there. Okay, let's look at this distributive property again. How do we apply it in this particular example? Well, we multiply a binomial, two terms. We multiply this bracket by 2x. So the whole term 2x needs to be multiplied by 3. So we have 2x times 3, and then plus 2x times y. Obviously, we don't need to write this half step. This is only to show how does this distributive property work. However, when you actually perform those operations, it would be nice to write at once 6x. Do it in your head. 2x times 3 is 6x, 2x times y is 2xy, and that will be the final answer. Now, avoid using distributive property when it actually doesn't apply. For example, if we have 2x times 3 times y, there's times everywhere, right? So we don't have any distribution. There's no addition or subtraction in a bracket. There are some brackets, but there's no operations within those brackets. So some people are making mistake by rewriting this expression as 2x times 3 times 2x times y. That doesn't work. This is incorrect. So distributive property distributes the multiplication over addition or subtraction, not over another multiplication. And let's review some terminology. A term. What's a term? Quite often we will refer to a term. For example, this is a term 6x, that's another term 2xy. A term is a cluster of letters and numbers connected by a multiplication. So it's a product of numbers and some variables, but it may include variable expressions. So for example, this would be just one term because it's a cluster of letters, x, numbers, 2, and expressions in a bracket. It's only one term. However, here we have two terms. First term, then it's addition, and another term. Clusters of letters, numbers, and expressions connected only by multiplication. Here are the examples. 2x, it's a term. Pi r squared, another term. Negative 2/3 x times x minus 1 in a bracket. It is a term because negative 2 over 3, it's a number, x is a letter, and here we have a bracket and expression. Everything connected by multiplication. Another term, negative x squared y, or as simple term as just 1. Those are all examples of terms. Some terms are considered to be like, and the others are unlike. For example, the like terms are the ones that will have the same variables raised to the same powers. So it's not only the same variables, but each of them needs to be raised to exactly the same powers. So basically exactly the same label. For example, we have like terms here, 2m, negative m, m over 2, but these terms are not like, even though they have the same letters. But here x is squared, and over there x is to the first degree. Similarly with y. Y is to the 1, and here's y to the 2. So those are unlike terms. Only like terms can be added or subtracted. Okay, so let's try to add or subtract. That means combine like terms. How do we do that? By adding their coefficients. If we need to combine like terms, and they are various terms with different exponents, customary we start with the highest exponent terms. I would suggest that you will underline all like terms and then try to add them. So we have 5x squared minus 3x squared. It's like 5 apples minus 3 apples. We work on coefficients only. 5 minus 3 is 2. 2 of what? 2 apples. And my apple is x squared. So it's 2x squared. Next, we can add terms that include only x. So we have x over 2. What is the coefficient by x over 2? Well, that's like 1 here. So it's really 1/2 x. X over 2 can be written as 1/2 x. That's the same. So 1/2 x minus, and what's this coefficient? Well, it's 1. If you don't see anything, you can always put 1. Okay, so we have 1/2 minus 1. How much is 1/2 minus 1? That's negative 1/2. Of what? Of x. Negative 1/2 x to put together these blue terms. And finally, we can use different underlining here and there for combining free terms. That means just numerical values. 2 plus 1 is 3, so it's plus 3. And it's done. Okay, now we have 2 more examples to practice on your own. So please try to release those brackets. Remember the rule that anytime you have a negative number or just a single minus in front of a bracket, to release the bracket you have to switch signs inside the bracket because you multiply by a negative number. So multiplying by a negative causes switching signs into opposite. So please do it on your own, pause the video, and after a few minutes come back and check. Okay, when we release the bracket, this minus will cause that these two signs will be reversed. So instead of negative 3x, we have positive 3x, and then this positive becomes negative 6y. Here again, multiply by negative 2, so it becomes negative 2x, and this times this becomes 2 negatives, makes it positive, so it's positive 6y. Okay, that's not the end. Now we try to combine like terms. Let's put together 3x and negative 2x, leaving us with just single x, and put together the y's. But we are quite lucky here because negative 6y can be cancelled with plus 6y. They are opposite, so they annihilate itself. Therefore, the final answer for this question is just an x. Okay, let's do the second example. Now we need to multiply, so let's multiply numbers first. 3 times 2 is 6, and then x and y needs to be written as it is. And here we have a multiplication by a bracket, so we need to apply our distributive property. Negative 5x times y, it's negative 5xy, and negative 5 times negative 2 is positive 10x. Finally, minus 7. Everything equals. What are our like terms? The 6xy and negative 5xy. 6 minus 5 is 1, and 1 doesn't have to be written, so it's just xy. Then it's plus 10x and minus 7. That will be all. Well done.